This tutorial is going to cover the perfect square rules. So the perfect square rules is where we go from something like a plus b squared and we get a squared plus 2ab plus b squared. Now you can show this using the distribution property where we have a plus b and then a plus b. Now, in order to use this to factorize, we can actually do the opposite process. So we had a plus b squared and a squared plus 2ab plus b squared. The opposite direction says that we're going to have a squared plus 2ab plus b squared can be factorized to a plus b squared. Now all this jargon, what it really means is that if we have 2 times, or this middle term, is 2 times the first and last terms, then you can factorize to this. Now, if we don't have pluses in here, for instance, we have a minus and a plus, then you can still factorize using difference of perfect squares, where the middle term will be, or the middle sign will be a negative, so a minus b squared. So a minus in here transfers to a minus in here. Let's just look at a few examples of these. Examples. Factorize the following. Example A is u squared plus 8u plus 16. The first thing to note is that 16 can be written as 4 squared. So u squared plus 8u plus 4 squared. Now the first term and the last term won't change, but we're looking at whether or not that middle term is 2 lots of u and 4. So 2 times u times 4. And in this particular case it is, so it meets this requirement for this to be a perfect square rule. So 2 times u times 4, because this works to give us 8u, we can then factorize this to u plus 4 all squared. I say plus 4 because we're dealing with 2 positives in our equation. If we look at example B, where we've got 3p squared minus 60p plus 300, our first step is to remove that 3. So that 3 needs to be removed because we don't want to deal with a larger value. We can, but it's just not ideal. So removing that 3, we're left with p squared minus 20p plus 100. Again, we're going to rewrite this with our p squared, and instead of 100, we're going to use 10 squared. The middle term will be 2 times p times 10. This here meets the requirement for our second perfect square rule, which means that we can factorize this using a as p and b as 10, giving us a rule of 3 bracket p minus 10 all squared. So this is using the perfect square rules, where we recognize that the middle term is 2 lots of the first term and the last term, giving us our expression that we're required to get.